Then my presentation is on the solar control and the related quality check concerns for Spain. In Spain, we have a complete building technical code for energy requirements and energy performance certification. And I have prepared a short presentation, 15 minutes at maximum, which will be distributed in this manner. First, we will speak about a context. What are the minimum requirements for energy consumption in buildings in the building technical code? Only the energy sections here in Spain. Then we will realize that there isn't any mention to the solar control there. So where is solar control there? I will make some comment. Then we will speak about the parameters which are relevant. The thermal transmittance and solar factor is obvious, but also the shading factor. The shading factor is the main concern of this webinar. Then let's speak about the minimum requirements. Spain adopted a direct limitation of the non-renewable primary energy consumption for buildings as the minimum requirements for the Directive for Energy Efficiency of Buildings in the section HE0 of the Building Technical Code. This is different for residential and tertiary buildings. For residential, we have a formula, you see, which is fixing the maximum amount of energy that can be consumed, including the heating, cooling, and domestic hot water services. And you see, it's a formula which is a number, the energy, the limit of energy base, plus a term which is depending on the size of the building. This is the surface, the area of the building. Then, as the building is bigger, the limit is lower. Then, for you to understand better, this is the climatic zone for winter in Spain. This is letter from alpha, then A up to E, and you can see here the colors for the map of Spain. And then for apartment buildings, you see the numbers we obtain up to 70 is the maximum, and unifamiliar buildings we have bigger limited. You see the apartments are bigger, then the limit is lower than unifamiliar buildings. Then this is more or less in line with limits in other European countries. Then the building must consume less than this amount of non-renewable primary energy. Then, in the case of tertiary buildings, the limit is linked to the energy performance certificate. Then the buildings are required to be at least of class B. That means that the consumption must be maximum 65% of the reference building. Details of the reference building are not able to be included here. Then, in addition to this limit fixed by the document HE0, there is another document, the HE1, which is a requirement concerning the net energy demand for heating and cooling. Then, again, for residential building is different than tertiary buildings, and here you see for residential building, the limit for the heating is based in a similar formula, a similar equation. Again, depending on the climatic zone for winter, you have different limits. The bigger the building, the lower the limit. This is for heating, and for cooling there is just a simple limitation. It's 15 kilowatt hours per square meter and year for the, let's say, the not so hot climatic zones in Spain, the 1, 2, and 3, and the limit is increased to 20 kilowatt hours per square meter and year for the hottest climatic zone, the 4th. Sevilla, for example, where I am speaking now, is in the climatic zone 4. Then, for tertiary buildings, the limit is set in terms of combined net energy demand for heating and cooling. This is a ponderated addition, weighted addition. And here you can see in terms of the internal gains in the building from low to very high, and the climatic zone, you have different limit of reduction against the same number for the reference building. Then this is the minimum requirement fixed here in Spain. Then you see there are no references to solar control. In fact, there are no explicit requirements for the glazing characteristics parameters, nor for those of the walls, just the requirements mentioned before. I mean, in Spain, building manufacturers, let's say, can make the building as they want. The only requirement is to fulfill the previous numbers. Then, just the glazing, the shading devices, everything in the building is just there. Then the energy consumption, the net energy demand are calculated as the directive is saying in standard conditions, and then it is affected obviously by the parameters used for characterizing every one of the elements in the building, from the glazing to the technical system, the boiler efficiencies, and things like that. Well, in what the glazing respect, we have no surprises. We are using the classical thermal parameters, the thermal transmittance, the solar factor, and of course the shading factor for taking into account shading. Shading is one of the most important parameters because of the solar radiation, especially in Spain, in which we have a very intense solar radiation during most of the year. The shading factor is a good way for controlling the demand of cooling, which, have you seen, is the limit is set very low. Then, from the point of view of QUALICHeCK, I have been suffering these differences in relation with other European countries, because of here we have no direct requirements for any of the parameters. We only need to have compliant buildings, and a compliant building includes compliant components, but in fact there are nothing to be controlled, except that the manufacturers must obtain the CE marking, and then the control is done by this CE marking. The elements must have its CE marking, and what is installed in the building must be what is declared in the project of the building. Well, a few words concerning thermal transmittance and solar factor. Is as I have just said, the technicians making the verification of the building technical code or obtaining the EPC for the building must use products that should have been obtained the CE marking. Then we rely on the reliability of the manufacturer data. The Ministry of Public Works, in charge of these matters in Spain, prepared a long time ago, with the help of manufacturer data, a database of window products. These are indicative values because of the CE marking required. Then the thermal transmittance for the assembly of glass and frame are calculated following the ISO and EN standard 177, and the solar factor is also calculated according to standards. Must be checked for every single product. We can have same thermal transmittance and a wide range of solar factors, and there is indicative values in this table, which is included in the software database, and as I said, it's just indicative. The final numbers must be the one actually installed in the building. This is for transparent system, and this is for the frames. Concerning the shading factor, well, the data for shading and shading factor products also are subjected to the CE marking, and we have no problem with that. But the problem is that usually shading products are mobile, and are mobile at runtime. I mean, the user decides at every moment how is the awning or the shade installed, or how height is it, or whatever, or is open or closed when. For fixed elements, for example, for fixed awning, an awning which is installed and is quiet during stable during the whole summer, we have here as a function of the transmissivity of the material. This is opaque and this is translucent. You see, and the orientation and the inclination, the angle of the system in two different positions. You see the shading factor which should be used. But this is when and there are other examples for other configuration. Well, this is when the system is fixed and is not operating. What happens when it is moved along the different days on the summer? Really, we have some uncertainty, but we have to give a number, and the number is given assuming this standard condition. The awning is set in the position that the project is indicating. In the software, we can take into account these fixed position shades, and we can see here the awning, the side fins, or our hands, and here the lamellas, the slats shades in horizontal or vertical position, and the software is taking into account. There is a detailed model for calculating the impact of this on the results, and this is included, and there are no problems. I prepare an example. This is an office building, just one story, and you see it's completely glazed in all the orientation. And if you include no shading in alpha climatic zone, which is the Canary Island, for you to imagine, we see that we don't fulfill the requirement, because we have just above the limit. This is the reduction applicable to this building, and we see we are just above the limit. We are red. We don't comply. Well, installing an awning there in the three, not in the north, but in the southwest and east orientation, we obtain a reduction on the combined cooling and heating demand of 30.6%, and we can see that we can comply. I mean, the relevance of the shading product is considerable, because we can pass from not complying to complying. Then shading devices is very important in our climates. This is very particular climatic zone. For one more normal in the south in the center east of Spain, we have in the hottest place, the B4 zone. The situation is more or less the same. This is the limits are different. You can see when you see the slides with a little bit more time, you see that the limits are different, but you see the situation is the same. With no shading, you can't comply the limit of the combined heating and cooling demand. And installing the same awning as before, we are, you see, below the limit, not so. The reduction is a little bit lower than before, but it's enough for fulfilling the minimum requirement, only 24.2% of reduction. Well, this is for the fixed shading devices. For other shading devices, when the user knows that it is movable mobile shades, then we have to rely on seasonal values for the shading factor. And the seasonal values are included in these two parameters, when the shade is installed and when the shade is not installed. And These numbers must be calculated by simulation. So you have to know what type of shade are you using, and then you will put here the name. If you can prove that the shade, the seasonal value of this shade is correct, you must use 1. I mean, if you put there a number which is not 1, you have to prove that you have calculated somewhere, somehow, the reduction, the shading factor. The parameters are complex, are based on the physical properties of the shading material, which are wavelength dependent. Of course, the geometry and the relative position of the zoom beams to the shade, which is Orly dependent, and also the operation of the shading, which can be fixed or scheduled Orly dependent, and this dependency can be on solar radiation, temperature indoors, or the level of lighting, or whatever else. For these special shading systems, we have included, and for other reasons, we have included in the national official tool, Unified Tool Leader Calendar, is called, a mechanism named additional capabilities, in which we can include, you see, this, for example, is the shading coefficient for the glass for the hole, the glazing. In summer, we can include different type of values. For example, hourly values during the whole year, and these values should be calculated also by simulation and must be included. And this is all my presentation. Thank you for your attention. And Alexander, should I stop the sharing?
Yes, you may. That's fine. And
okay.
I will make the presenter. Thank you, Jose.
Thank you.
And the floor is yours.